This lesson is going to discuss fractional exponents and their relationship to radicals. So you'll notice that the small number on the outside, which is located here, that is called the index. The radicand is the number that is inside of the radical. So for example, if the index was 3, I would be looking for a third root, or what number multiplied by itself 3 times would result in the radicand. Now I can take this information and translate this into a fractional exponent. So the index gets translated to the denominator of your fractional exponent, and the exponent that would be on the radicand becomes the numerator of your exponent. So we're going to practice with this. So if I'm dealing with these 4 examples, I'm going to take the radical form of those 4 examples and translate them into exponential form. So if you look at x to the power of 2 inside of a cube root, or an index of 3, x is going to remain the base, and the exponent now is going to be 2 over 3. You don't have to write your fraction sideways like this. You could write a stacked fraction like so, but because I don't have enough room, I'm going to write it as a slanted fraction bar, which doesn't change anything at all. So for the next example, since there is no index, I have an imaginary 2. So since there is an imaginary 2 here as the index, y is going to remain the base. The numerator of the fraction will be 5. The denominator of the fraction will be 2. The fact that the 7 out here on the third example is not inside of the radical doesn't change anything we've done so far. Z will be our base, 7 is still going to be our numerator, and 4 will still be our denominator. This last example, just like we talked about in class yesterday, if there is no exponent listed, it is automatically assumed to be a 1. So I would have a to the power of 1 over 8. We're going to practice with these a little bit more. So now I'm going to give you the fractional exponent, and you need to turn it into a radical. So for example number 1, 6 becomes the index. X goes inside as your radicand, and I have an not imaginary, but we know that this 1 is implied by not listing the 1 there. You could write x to the power of 1. You would not be incorrect, but if it was a multiple choice question, you would not see the 1. Switching over to example number 2, 4 in the denominator becomes our index. And now I'm dealing with 3x all raised to the power of 3 as the radicand. Because of the exponent rules that we talked about in class yesterday, I'm going to apply the 3 to both pieces. So I'm still going to have a 4th root, but now it is 3 to the power of 3, x to the power of 3, and 3 to the 3rd power is 27, so I can simplify that one step further and say that it is the 4th root of 27x to the 3rd. Last example from this section, I don't like dealing with a negative exponent, so I am going to switch that. And we know from class yesterday that in order for me to make a exponent switch from negative to positive, it needs to live in the other side of the fraction. So I've switched everything to the denominator. Now I'm going to take the 9 and make that the index. And I have the entire piece, 5a, with the exponent of 7. I'm going to take that one step further and say that this is the 9th root of 5 to the power of 7, a to the power of 7. And I'm going to leave it here at that because 5 to the 7th power is a very large number, and I don't want to deal with that. Now going from from the radical to a fractional exponent. Now, just like we talked about on the last example, this whole piece inside of the radical needs to get the exponent. So the entire thing of 4p is going to get an exponent of 5, and it's going to be divided by 2 because that's my imaginary index. And that would be your answer for number 1. The reason number 2 is a little bit different is because the only thing inside of the radical, the only radicand that I have, is x. So I don't need to put parentheses around this when I write my exponent. I can just write 10 thirds. Going on to the last example, 2 in the numerator will not change with that radical being in the denominator. So I'm going to rewrite this as y to the power of 5 over 6. So now that you know where fractional exponents came from and what they are related to, we're going to look at some examples. Putting together fractional exponents and the exponent rules from yesterday. Now in class yesterday we talked about how there are multiple ways to go about beginning these problems. Regardless of how you would choose to start this, you would still arrive at the same answer. Now me personally, I'm going to go ahead and combine these two pieces that are both y's. And I'm also going to notice that I have a 3 in the numerator and the denominator. And because the 3 in the numerator and the 3 in the denominator don't have any extra exponents, there's nothing else happening to them, I can cancel them out. So let's start simplifying this a little bit. I'm going to leave y to the power of 1/4 in the numerator for the moment. I'm going to leave 4 in the denominator because that hasn't canceled. X to the power of negative 2/3 can go up to the numerator because I do not want a negative exponent. And then I'm going to take 3 halves and 1/2 and add them together. So 3 over 2 plus 1 over 2 would give me 4 over 2, which simplifies to 2, so y would have an exponent of 2 in the denominator. Now I see that I've got y to the power of 1/4 in the numerator. Did not mean to erase that. Wanted a highlighter. So I can take y to the power of 2 and y to the power of 1/4, and I'm going to simplify one more step. These 1/4 y in the numerator are going to come to the denominator and be subtracted because 2 is larger than 1/4. So 2 could be rewritten as 8 over 4, and then I'm going to subtract 1 over 4 from that. So x to the power of 2/3 is going to stay as it was in the numerator. 4 is still in the denominator. Because of this subtraction over here, the new exponent on y is 7/4. And that would be my final answer. And here's our last example. Again, a couple different ways of going about this to start. What I'm going to do is I'm going to take these exponents that are the same base, and I'm going to combine those together, and then I'm going to deal with the extra exponent of 2. So first and foremost, I have to deal with -1 plus -4/3. You could do this in your calculator. That is totally fine. But I'm going to change -1 into thirds. So that would be -3/3. And I am adding -4/3 to that. -3 plus -4 becomes more negative. So that would be a to the power of -7/3. Now I got to figure out b. So I have 1/3 plus 2. So 1/3 plus how many thirds would be 2 whole? So I've got 6/3. So I've got b to the power of 7/3. You could choose to move a to the -7/3 to the denominator, or you could multiply. I'm going to multiply. So this becomes a to the power of -14/3 and b to the power of 14/3. So final answer, b to the power of 14/3 stays in the numerator because it's positive, but a needs to be moved to the denominator so that 14/3 is positive for a.